We now discuss the solution of the problem from the section Sets, Relations and Functions. This question is on 1, and on2 functions. This question has appeared in the Joint Entrance Examination Main held on 26th June 2022 in the second shift. The given question is, let f be a function from the set of real numbers into itself defined as f of x is equal to x minus 1, and g is a function defined from r minus the set consisting of minus 1 and plus 1 into the set of real numbers, and it is defined as g of x is equal to x square by x square minus 1. Then the function f compose g, that is the composition of f with g, f compose g is, we are given four options. We are given four options. Option A, 1 to 1 but not on to. Option B, on to but not 1 1. Option C, both 1 to 1 and on to. Option D, neither 1 to 1 nor on to. We have this function f from r to r defined as fx is equal to x minus 1. We have g defined from r minus the set consisting of minus 1 and 1 into r defined as g of x is equal to x square by x square minus 1. Then f compose g is it 1 to 1 and on to. So we have to decide these two properties, 1 to 1 and on to ness, and we have to find out which option is true. We now discuss the solution of the problem in detail. We have f of x is equal to x minus 1. We have g of x is equal to x square by x square minus 1. Notice that g is defined from r minus the set consisting of minus 1 and 1 into r. This is g. And f is defined from r to r. So f compose g is defined from r minus the set consisting of minus 1 and 1 into r. So note that f compose g is defined from r minus the set consisting of minus 1 and 1 into r, defined by f compose g of x is equal to f of gx, that is, and f of x is x minus 1, f of gx will be gx minus 1. So gx is x square by x square minus 1, and there is another minus 1, and take the LCM, that means, in other words, simplify, you will get that is equal to 1 by x square minus 1. Thus f compose g of x is equal to 1 by x square minus 1 for all x belongs to r minus the set consisting of minus 1 and 1. So the domain of f compose g is r minus the set consisting of minus 1 and 1, and the codomain is r. Agreed. Now we talk about whether this f compose g is 1 to 1 or not. Observe that f compose g of minus x is equal to 1 by, wherever there is x you write minus x whole square minus 1 in the denominator, that is equal to 1 by x square minus 1, that is equal to 1 f compose g of x for all x belongs to the domain of g, the domain of f compose g. Agreed. That means this tells you that it is an even function. It is an even function, and this implies f compose g maps two distinct elements x and minus x of the domain, that is r minus the set consisting of minus 1 and 1 onto the same element 1 by x square minus 1. So that means two distinct elements are mapped to the same element. So that is f compose g is many to one function. So f compose g is not 1 to 1. So the 1 to 1ness is not there for the function f compose g. The on to ness we will discuss in the next slide. We have already shown f compose g is not 1 to 1. So to show the on to ness, consider the range of this F composed G. And if this range of F composed G is not the codomain of F composed G, namely R, is not equal, then it is not onto. If it is equal, then it is onto. The range of F composed G is equal to the set of all y belongs to R such that y is the image of X, image of all X under F composed G. So X is from the domain R minus the set consisting of minus 1 and 1. Agreed. So y is equal to F composed G of X will imply y is equal to F composed G of X is 1 by x square minus 1. And cross multiply, x square minus 1 is equal to 1 by y. Simplify, you will get x square is equal to 1 by y plus 1. Take the LCM, you will get x square is equal to 1 plus y by y. For any x square is non-negative. So this will imply 1 plus y by y is greater than or equal to 0 because x square is greater than or equal to 0 for any x. Right. So let's go and talk about the range of F composed G. The range of F composed G is the set of all y belongs to R, because we are in the codomain, such that 1 plus y by y greater than or equal to 0. So if y is greater than 0, that is y is positive, then 1 plus y is positive by y positive. So that means it is 0 to infinity, it will give you. If y is equal to minus 1, it will be 0. If y less than minus 1, then 1 plus y is negative by y less than minus 1, y is negative, negative by negative, it is positive. Therefore, it is equal to minus infinity to minus 1 is included, union the open interval 0 to infinity. And you can't take y is equal to 0 because y is sitting in the denominator. So that means the elements minus 1 to 0 included, that is the semi-closed interval, minus 1 open to 0 included, those many elements are not included here. That means they are missing. That means this is not equal to the codomain of F composed G, that is the whole of R. Is it whole of R? No. So note that the range of F composed G is not the codomain of F composed G, that is R, is not the whole of R, that is not the codomain of F composed G. Therefore, it is not onto. So we have already shown it is not 1, 1. Now we have shown it is not onto. Therefore, F composed G is neither 1 to 1 nor onto. Let's look at our options. And our answer is appearing against option D. Therefore, our answer to this question is option D. That is the detailed discussion of the solution of the problem from the section, unit section sets, relations and functions, and the question is based on the concepts of one-to-one and onto-ness. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.